My name is Tanisha and today we will be learning about exoplanets. So, in this session, what we'll be doing, we will be understanding what exactly exoplanets are, learning why the research is so important, taking a look at different methods of detecting exoplanets, and even taking a deep look into the working principles of behind the popular methods of exoplanet detection. And I'll also be showing you a light curve, just an example of a host star with an exoplanet orbiting around it, so you can get a better understanding. So, what exactly is an exoplanet? Simply put, it can be defined as any planet outside our solar system. And just like how the Earth orbits the Sun, these exoplanets usually orbit a host star. And if they don't orbit a host star, then they're known as a rogue planet. But we won't be getting into their detection methods today. I'll just be talking about um, exoplanets orbiting around their host stars, how those are detected. Now, how do scientists detect exoplanets? There are many different methods through which this can happen, um, and some of them are shown over here. The radial velocity method, transit photometry, or just the transit method, gravitational microlensing, and direct imaging. Now, out of these four commonly used ways, the most popular and the most successful ones, and by successful I mean the ones which have detected the most exoplanets, are the transit method and the radial velocity method. The transit method is the most successful out of all of them. So I'll be going over that first. So what is a transit exactly? Now, a transit is the phenomena that occurs when a planet or an obstacle passes between a star and an observer. During this process, the light emitted by the star is perceived as less by the observer. It gets dimmed, you could say. And this can be, and then the dimming of light can be plotted on a graph of brightness versus time. And this graph is known as a light curve. Let me just show you over here. This is a light curve. So brightness or flux, in other terms, versus the time period of the orbit. So when the light emitted by the star is dimmed, you can observe a small dip in the light curve. So when the planet orbits around the star, it'll regularly cause dips in the brightness of the star, and it can be observed like this. Now, by analyzing these light curves, um, the scientists can understand how whether there is an exoplanet in front of the star. And analysis of the atmosphere, all like the full chemical composition of the atmosphere on the exoplanet, can also be done using during a transit. So the different elements making up the atmosphere of that exoplanet, it would be able to scatter the light emitted by the star on a particle level, and this scattering can be closely observed on spectrographs. And this is how scientists can understand the chemical composition of the atmospheres and determine whether exoplanets may be habitable for humans in the future. Now, the transit method has helped identify many different planets and deepened our understanding of the universe. Scientists are working on developing future telescopes to improve detection, leading to discovery of multiple Earth-like planets that we could inhabit in the future. And the search is just beginning. So you could also be the next scientist or astronomer contributing to space exploration. Now, let's just talk about the next method, the radial velocity method. This is also quite popular after the transit method, and it works on the principle of the Doppler effect, one of the applications. It's one of its applications. Now, let's just take a look at some of the background information on the Doppler effect. So, the Doppler effect can be defined as the apparent change in frequency of the light or sound waves emitted by a source when there is relative motion between the source of the sound or light waves and the observer. So you could just take a look over here. This ambulance, it is moving towards an observer. It is moving towards an observer over here. So there is relative motion and the frequency of the waves seem more compressed, so the frequency increases. This increase in apparent frequency can be observed and similarly just behind the ambulance, which is moving away from the observer B, the apparent frequency of the waves emitted is decreased. So this is just an important general concept to look at when talking about the radial velocity method. Another important concept is gravity, gravitational attraction. So what exactly is gravity? It can be defined as the mutual force of attraction which pulls two bodies together, separated at some distance. So just like how the Earth pulls us towards its center, we actually pull the Earth towards ourselves. But because our mass is much, much, much less compared to the Earth, this pull is usually ignored. It's negligible because the force of attraction is very small. But it still happens. And you can see in this diagram over here, the person is also the person, while being pulled by this planet, is it's also pulling the planet towards itself. Now, detecting exoplanets using the radial velocity method. So, compared to the host star, which can easily be seen through telescopes or images, the exoplanet orbiting around it is much smaller in mass and size. And this is why the star usually outshines its exoplanet. But we can use the principles of gravitational attraction and the Doppler effect to understand whether an exoplanet is orbiting around that star. So obviously there is a gravitational force of attraction between the host star and the exoplanet orbiting it. Since this force goes both ways, the exoplanet also exerts a small pull on the host star and causes it to wobble or shift around in its orbit. This can cause relative motion between the star and the observer on the Earth. Seeing this through a telescope or maybe even a satellite, and the apparent frequency of the light emitted changes. This change in apparent frequency causes obviously a change in wavelength. So This change in wavelength is analyzed on a device known as a spectroscope by scientists. And if there is a regular and periodic change um, on the spectroscope, then it can indicate to scientists that there is an exoplanet present. And that's all for today. This is the radial velocity method. Thank you for listening.